do you mean by scales? A scale is a medium through which we can increase or decrease the dimension of an object. You will see the scales in a map also. When you see map, on the right hand side corner you will see scales. So scales are generally used in maps. Architecture, they use scales to reduce the diagram because it is not possible for them to draw actual size of the building. So what they do, they take a scale and they draw a smaller diagram to represent a bigger picture. And we have two types of scale. One is plane scale and one is diagonal scale. Now before going for this plane scale and diagonal scale, I would like to explain you RF. RF is a representative fraction, and it is basically ratio of length of the drawing upon actual length.
Let's say if you want to draw this T square, right, on your board. So I don't think so it is possible if you'll be able to draw with the scale, like actual dimension. And I'll draw one simple diagram, a small diagram, maybe a 6 centimeter long. Let's say I'm drawing 6 centimeter. But what is the actual length? 60 centimeter, right? So what I have done, I have reduced the actual size by 10%. Instead of 10 centimeter, I'm taking 1 centimeter, right? So this is called representative fraction. That is drawing length upon actual length. You understood? So for this, RF is how much? 1 upon 10. That means if I draw 1 centimeter, so in actual sense it will be 10 centimeter. Now I'll just explain you the basic concept. Whenever you want to start any scale diagram or whenever you want to solve any scale sum, that time you should know three things. First is RF. You should be aware about RF. Second is maximum length. And third is units. That means in which unit you want. You want meter, decimeter, centimeter and all. We will see one formula that, okay, now we know that RF is equal to drawing length upon actual length. I can write drawing length as length of scale and actual length as maximum length, right? So RF will be length of scale upon maximum length. So I can write length of scale is equal to RF into ml. So remember this, length of scale will be equals to RF into maximum length. Before starting with the sum, I'll tell you we have two types of scale. One is plane scale and diagonal scale. So first we'll start with plane scale. Now they have given construct a plane scale of RF 1 upon 20 to read up to 3 meters. Mark 2.3 meter, 1.2 meter and 0.8 meter on it. Now if you see in this case, they have given RF. So RF is how much? 1 upon 20. Now what do you mean by 1 upon 20? That means 1 is on drawing length and 20 is actual length. Then they have given read up to 3 meter. So maximum length is how much? 3 meter. Mark 2.3 meter on it. That means they want us to mark 2 meter and 3 decimeter, right? So we have to mark meter as well as decimeter. So now we will use our formula that length of scale is equal to RF into ml. So what is RF? RF is 1 upon 20. Maximum length is how much? 3 meter. Now see, we have a scale in centimeter. So what we will do, we will multiply this with 100. So it will be 15 centimeter. So we will draw a line 15 centimeter long. This is 3 meter. Actual sense में if you see 3 meter and what we got is 15 centimeter. So 15 centimeter is drawing length and 3 meter is actual length. So even if you do ratio of this 15 centimeter upon 3 meter, so that is nothing but 15 upon 300. If you find out, it will be 1 upon 20. You understood? So in exam, they might give you a sum like this. Construct a plane scale where 15 centimeter is marked as 3 meter, right? So that time we have to find out RF by this way, like keeping 15 centimeter upon 3 meter, 15 by 300 equals to 1 upon 20. Now we have drawn the scale. Now if you see scale, it will have a scale will have height also. So we will take height 5 millimeter. Now we can take whatever we want. Generally, I have seen people taking 6 millimeter, 9 millimeter, even 2 centimeter. You can take whatever you want. So I have taken 5 millimeter. So this is my plane scale. Now this is how much long? 3 meter, right?
Now always remember, whenever you want to divide scale, you should always pay attention to maximum length. Now in this sum, maximum length is 3 meters, so we will divide into 3 parts. I know a lot of people, they have doubts. So always remember, you should divide according to the maximum length. If maximum length is 5 meter, you will divide into 5 parts. If maximum length is 2 meter, you will divide into 2 parts. So main division, it depends upon maximum length.
So what we will do, we will draw one angle and we will divide this into 3 parts. So we can mark meter on it, 1 meter on it. While in this sum they want us to mark 2.3 meter, that means 2 meter and 3 decimeter. 1.2 meter, that means 1 meter and 2 decimeter. 0.8 meter, that means they want us to mark 0.8, means 8 decimeter. So what we will do, we will draw one line and we will divide this line into 3 parts. So we will take any arc in a compass, cut 1, 2, 3. We join this to this, and afterwards we will draw a parallel line. See, it is important to show division, even if it is divisible by 5. Like few people, they have asked me, okay, sir, this 15 centimeter we can easily divide into 3 parts by marking 5, 5, 5. But we have to show this method. So we have divided this line into 3 parts. So this is 1 meter, 1 meter, 1 meter. Now we have to mark decimeter as well, right? So 1 meter is 10 decimeter. So what we will do, we will divide this first block into 10 parts. We'll take around about 1 centimeter and we'll cut 10 equal arms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We will join this point to this point. Now we will draw a vertical line from here. Now we will start from here, 0, 1, 2. Now you will have a doubt, like why I have started 0 from here. So now see, if I take any diagram, if I start 0 from here, 0, 1, 2, 3. Now I have to mark 2.3. That means I have to divide this line into 10 parts. 1.2. That means I have to divide this line into 10 parts. 0.8. That means I have to divide this line into 10 parts. If I want to mark C, 0.8, 1.2, 2.3. So it is very much time consuming. So what we do generally, we leave one block and then we do it this way. So now I want to mark 0.8. So I can easily mark 1, 2, 3, 4, 5, 6, 7, 8. I can mark 0.8 over here, 1.2, This is 0.8. Right? This is 1.2. This is 2.3. Understood? Now we can write meter over here. We can write decimeter over here. We can write RF in the middle, 1/20. Now at times what happens, it becomes, now since this is very small, in the sense, this height also, as well as this can be also very small. Let's say any layman, if he wants to use this scale and if he wants to see it properly or clearly, so for that purpose what we do, we take 2 mm from down and 2 mm from the up, and we'll draw horizontal line. So we will get a gap of 1 mm. Now we will shade this block first, 0 to 1. And then I'll keep on darkening all the alternate blocks. So what will happen, if someone wants to use this scale, instead of going by counting 1, 2, 3, he can easily count the number of shaded and unshaded portion. Let's say if I want to take 0.3, then I'll take 2 dark block, like 1 block and second block. If you want even number, that time you take unshaded portion, and then you hatch. Then you just dark this portion. So if you take 5 mm, then it becomes very easier for us to take 2 mm from the down and 2 mm from the top, and we can shade this portion. And at times I have seen that they will ask you draw an equilateral triangle of 0.8 meter. So that time what you have to do, you draw one light line, take 0.8 meter in your compass, cut on this side as well as cut on this side. So we got a triangle of 0.8 meter. This is how much? 0.8 meter. This darkening thing is not necessary. If you wish, you can draw. If you don't wish, you can skip also.